Hello everyone, this is Prashanth. Let's continue with the last lecture in Internet of Things. Just we are talking about the controlling hardware devices in the IoT. In the last class, just I have completed unipolar and bipolar stepper motor applications, different type of applications, what are different types of sensors, different specification, advantage, disadvantage, real-time projects, like that we have to discuss, we have discussed in the last lecture, that is unipolar, bipolar, stepper motor sensors, that will complete in the last lecture. Now we move entering into that another controlling device, that is USB sensors and embedded sensors. So here USB sensors and embedded sensor. Before going to entering into the actual content of the class, first we have to know the what are the objectives and outcomes. So here USB sensors in IoT. Here our agenda is USB sensors in IoT and embedded sensors in IoT. So under USB sensors in IoT, what are the objectives here? Sensor is nothing but gathering the data. We know the initial thing, gathering data from environment for monitoring and control purposes. Examples include temperature sensors in greenhouses, pressure sensors in water systems, light sensors for smart lighting systems. So different sensor, different application, different sensor and application, like that. These are the objectives of USB sensors in IoT. And outcomes, provide real-time data for analysis and automation. This data can be used to optimize processes, improve efficiency, and gain insights into environmental condition. So that is the outcomes. So this is the first sensors in USB sensors in IoT. Next one, embedded sensors in IoT. What are the main objective of embedded sensors in IoT here? Collect data on a device's performance, internal working or surroundings environment. This data can be used for various purposes such as condition monitoring, predictive maintenance, or user experience optimization. So these are the objectives of embedded sensors in IoT. Outcomes, enable 1, 2, 3. Ultrasonic sensors in IoT. What are the main objective of ultrasonic sensors in IoT? Detect objects or measure distance and native surroundings. This is useful in applications like smart homes, robots, autonomous vehicles, and abstract avoidance systems. So these are the some applications: smart robots, autonomous vehicles, and abstract avoidance system, like that, under ultrasonic sensor in IoT. What are the outcomes based on the objectives here? Improve safety and automation in various IoT applications. Ultrasonic sensors can be used for tasks like object recognition, path planning, and collision avoidance. So the overall the objectives and outcomes of using these sensors in IoT project will depend on the specific applications, but generally they are used to collect data from the physical world, which they can be used to monitor and control automate process like that. So this can lead to increased efficiency, improved safety, and better decision making. So these are the ultrasonic sensors in IoT objective and outcomes. Next one, USB sensors. The main USB introduction points of USB sensor. While USB sensors are not the most common type of sensor used in IoT applications due to their inherent need for a wide connection, they can still be useful in certain scenarios. To develop the particular some specific scenarios, in that only the USB sensors we may use. Here's a breakdown of USB sensors, their applications in IoT, and why other options might be preferable. So that is the main reason why we are not using USB sensors for a particular IoT project. So understanding of USB sensors, we have some points here. USB sensors connect directly to a host computer or microcontroller board using a universal serial bus, that is USB. USB is just universal serial bus interface. So they provide a digital output signal that the host device can read and interpret. So that is the second point. Next one, they come in various types, measuring a range of environmental parameters like temperature, humidity, pressure, light, or even specific gases, just smoke detector system or gas detector system like that. So these are the some introduction points of how understanding USB sensors. Just next, applications of USB sensor, applications of USB sensors in IoT, rapid prototyping and development. The first applications of USB sensors in IoT. During the development phase of an IoT project, USB sensors offer a quick and convenient way to connect sensors to a computer for testing and data acquisition. So this is the first one. And data logging and monitoring. So here the data logging and monitoring, USB sensors can be used for simple data logging applications where collected environmental data is stored on the connected computer for analysis. That is the second one. And the educational use cases also, in the educational use purpose or learning about the sensors and IoT principles, the USB sensors offer a user-friendly way to interface with the sensors and visualize sensor data on a computer. So this is the some real-time exam applications of USB sensors in IoT. Then next one, limitations of USB sensors in IoT. Here, wide connection, the wide connection, limited mobility and power consumption also very high as compared with the other US sensor. Wide connection. The wide nature of USB sensors limits their replacement flexibility compared to wireless sensors. So almost we are in 2020, almost we are using wireless devices to connect with the help of Bluetooth or Wi-Fi. Just there is no need of wide connection of devices. In some cases, in particular some cases only, just we need a wide connection of devices here. So the same. So this is the one limitations of USB sensors in IoT. And limited mobility. The mobility also very less limited. The applications requiring sensors be placed in remote or hard to reach the locations. USB sensors become impractical due to the cable length constraints. That is the second one. The power consumption of very USB sensors are low power. They still require a wide connection to a powered USB port, limiting their suitability for battery powered IoT devices. So these are the these three limitations of USB sensors in IoT. And alternative to USB sensors in IoT, wireless sensors and microcontroller shields also alternatives. How they are using wireless sensors for most IoT applications. Wireless sensor using Bluetooth, Wi-Fi, or cellular mode. Just now I told with the help of Bluetooth or Wi-Fi, just headphones connected to the mobile or laptop or whatever system. By using same also, cellular communication offer more flexibility and scalability. They can be battery powered and placed in various locations without needing a direct physical connection. That is the simple one. And microcontroller shield also one of the alternative to use USB sensors in IoT. Some microcontrollers have dedicated shields or add-on boards that integrate various sensors, eliminating that the need for separate USB sensors and simplifying the connections. So these are the two alternatives to use USB sensors in IoT: wireless sensors and microcontroller shields. Next one, when to consider USB sensor for particular developing applications, rapid prototyping and testing during deployment stages. So that is the main use cases of USB sensor. Rapid prototyping and testing during development stages. Second one, educational purpose are learning about the sensors, basic data logging that is just used to develop, and applications where a computer is always nearby to provide power data and data collection. So these are the three main reasons to consider USB sensors. Thus, at the three cases, compulsory the need of USB sensors essential. In summary part, while USB sensors have a niche rule in IoT development, specific use cases, wireless sensor options generally offer more advantages for deployed IoT applications due to their flexibility, scalability, and suitability for battery power devices. So these are the some in the summary part. Next, after IoT USB sensor, just we have embedded sensors here. Embedded sensors are the backbone of the data collection in the Internet of Things world. They act as ears and ears. Sometimes even the nose of IoT device also. Ear, eye, and nose, constantly monitoring and measuring the physical world around them. Here's a deep dive into how they work and their significance of in IoT. So this is about the embedded system. What are the embedded sensors? Unlike traditional sensors that might connect to a computer via USB, embedded sensors are minimized and integrated directly into the IoT device. These are the what are the embedded sensors is called, and they come in a wide variety of each designed to detect and measure specific physical phenomena. Common types include temperature sensor to measure the temperature under the various conditions, like thermistor, and pressure sensor, piezoelectric material that is capacitive, and humidity sensor just to that is resistive and capacitive, and light sensor like for photodiodes and photoresistors, motion sensors, accelerometers, and gyroscope motors. Gas sensor in order to detect the gas detection system or identify the gas leakages. Electrochemical metal oxide semiconductor. So these are the some wide variety of embedded sensors. These sensors convert the physical quantities that measures temperature, light, pressure into the electrical signals. Just into physical quantity convert into temperature, light, temperature into the electrical signal. From the electrical signals only, just we may pass some information. These are the types of sensors embedded system, and why are the embedded sensors are important in IoT? In order to develop the some real-time IoT projects, just we need embedded sensors. That is the importance of embedded sensors in IoT. For that some particular reason, embedded system sensors enable IoT devices to gather real-time data about their environment, and this data can be used for various purposes, including here monitoring and control. Some thermostat use temperature sensor to regulate room temperature, while wearable use motion sensors to track activity levels. That is the first various purpose. And predictive maintenance. In order to predict the industrial equipment with embedded vibration sensors, it can predict potential failures before they occur. The second one, environmental monitoring. Air quality sensors can track the pollution levels in cities, and soil moisture sensors can optimize irrigation in the agriculture sector. So here, just depends on the domain also. Just we may use which type of embedded sensor to develop the particular project. So these and user interaction also. Motion sensors in smartphones allow for gesture control, while light sensors adjust the screen brightness based on the ambient light. So depends on the light whether available in the outside. Just the brightness also it will increase or decrease or neutral like that it can maintain. So these are the some use case of embedded system, and benefits of embedded sensors here. Miniaturization here. Small size allows for integration into compact IoT devices. That is the miniaturization. And low power consumption. It allows low power to consume. Many sensors are designed for low power key use, crucial for battery power devices. So that is the second one. And the third one is of use often requires simple interfaces for connection to microcontrollers within the IoT device. So this is the next fourth one, variety of options. So here the vast range of sensor types caters to diverse sensing needs in IoT applications also develop. These are the benefits of embedded sensors. Next, integration with the microcontroller here. Embedded sensors connect to the microcontroller and the brain of the IoT device, that is we already know. And microcontrollers can use read the electrical signals from the sensor, the first one, and convert the signals into meaningful data using calibration factors and calculations. That is the second one, and process the data and make decision based on sensor readings. That is the third one, and communicate the data to the cloud or other devices for further analysis or control actions. That is the fourth one. So, and these are the interaction with the microcontroller. So, choosing the right embedded sensor for developing the IoT applications here. Selecting the most suitable sensor depends on your project requirement. So, here what are you are measuring? In order to measure temperature, pressure, light, etc. So, what is the required accuracy and range for power consumption limitation and environmental factors? For power consumption limitations for battery powered devices, consider low power sensors, and environmental factors, choose sensors suitable for the operating temperature, humidity, or potential presence of corrosive elements. So these are the choosing the methods, right, embedded sensors to develop the IoT projects in real time. And the examples of embedded sensors in IoT, smart thermostat, it is temperature and humidity sensor for comfort control. That is the first one. Second one, wearable fitness trackers, mention motion sensors or track steps, heart rate sensors and temperature sensor, like that. The third one, smart agriculture system, soil moisture sensor, fluid detection system, forest fire detection system, temperature sensor and light sensor to optimize irrigation and crop health. And smart homes. In smart homes, motion sensors for security and occupancy detection, temperature sensors for thermostat, and leak sensors for water detection. Different applications for depends on the different applications. Just we make different applications, like for security, motion sensor, motion for security. For temperature, thermostat. For leak sensor, for water detection. For water detection, just we use leak sensors. So these are the examples of embedded systems in IoT. And industrial IoT, IIoT, vibration sensor for predictive maintenance, pressure sensor for monitoring industrial process, and gas sensor for leak detection. These are the examples of embedded sensors in IoT. These are the learning resource. Just you can type embedded sensors with Arduino in online, or sensor type for IoT projects. Just you will find the tutorials explained in various data sensor types, their applications, connection methods, code example, and project ideas. So this is the learning uses for these USB sensors and embedded sensors. Next, distance measurement with ultrasound sensor. Before, just we completed USB sensors and embedded sensor. Along with that, just we have to know about the distance measurement with ultrasound sensor. Distance measurement with ultrasound sensor. Certainly, in the real of Internet of Things, ultrasonic sensor offer a cost-effective and versatile solution for measuring distance. Here's a breakdown of how they work, their applications in IoT projects, and how to integrate them with the microcontrollers. So this is the some important point. Ultrasonic distance measurement principles. What are the principles having? Sound emission, echo reflection, time management, The sound emission, the defines sensor emits a high frequency sound wave, uh, ultrasound beyond the human range of human hearing towards the target objects. Second one, echo reflection. When the sound wave hits the project object, it bounces back and it received by the sensor. Time measurement. The sensor measures the time it takes for the sound wave to travel to the object and back. So these are the three principles of ultrasonic distance measurement sensor: sound emission, echo reflection, and time measurement. Calculating the distance from the sensor. The speed of sound in air is known as value, approximately 3.343 meters per second at a room temperature. By dividing the round trip time by twice the speed of sound, we can calculate the distance to the object. So that is the how the calculate distance from the one point to another point. And factors affecting the accuracy. Accuracy also affected by the some factors: temperature and object material. In terms of temperature, the speed of sound varies with temperature, so calibration might be needed for high precision applications. That is temperature. Object material, highly absorbent materials like thin contents might dampen the sound wave and affect accuracy. So these are the two factors affecting the accuracy. Next one, sensor angle. The sensor should be relatively perpendicular to the target object for accurate measurement. So this is the one more affecting accuracy factor affecting the accuracy. So next, temperature, object material, sensor angle also. In terms of temperature, the speed of sound varies with temperature, so calibration might be needed for high precision applications. That is the temperature. And object material, absorbent materials like thin curtains might dampen the sound wave of affect accuracy. And so last one, sensor angle. The sensor should be relatively perpendicular to the target object for accurate measurement. So these are the remaining factors affecting on the accuracy. Applications in IoT. Here for obstacle detection, here robots and drones can use ultrasonic sensors to navigate and wide obstacles. The second one, smart inventory management. Track product levels on shelves or in bins for inventory control also. The third one, liquid level measurement. Measurement the fill level of liquid in the tanks or containers. That is the essential thing. Smart parking system also comes under applications of IoT for the sensor detect the pressure or absence of vehicles in the parking spaces. Next, security systems also trigger alarms upon the detection movement with a specific range. These are the applications of IoT here. Uh, Integration with microcontroller. Most ultrasonic sensors have a simple digital or analog output. Here, digital sensors and what is digital sensor and what is analog sensors. Digital sensors output a high signal when sound is emitted and low signal when the echo is received. The microcontroller measures the pulse width to determine the round trip time. That is the digital sensors. Coming to the analog sensors, the output to a voltage is proportional to the round trip time. The microcontroller converts the voltage using an analog to digital converter before calculating the distance. So that is integration with microcontroller. Popular microcontroller platforms. Arduino offers libraries and tutorials specially designed for ultrasonic sensor integration. Raspberry Pi. This is the microcontroller platform Arduino and Raspberry Arduino Uno. Popularly, just we use Arduino Uno, Arduino Mega, Arduino Core, Arduino. Different types of Arduino modules are available, but we are using Arduino Uno. Raspberry Pi, it can be programmed with Python and interact with the ultrasonic sensors also. Next, learning resources. These are the just you can type just ultrasonic sensor with Arduino or ultrasonic sensor for Raspberry Pi. just you will find numerous tutorial explained, like sensor connection method, hardware, code example for distance measurement, project ideas utilizing sensors, ultrasonic sensors in IoT application. These are the some learning resources with the help of chat GPT, like that. So standard kits for microcontroller often used to include ultrasonic sensor, providing a hands-on learning experience for working with the distance measurement in IoT. These are the learning resources. So these are the USB sensors and embedded sensors, along with different types of sensors. I will explain here. Remaining continue with the next lecture. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.